Okay, so we know what an exponential function is now. If I was to sketch an exponential function, so for example, y is 2 to the x on a graph, and I was to sketch its gradient function, then it will look something like this here. If I now sketch y is 3 to the x along with its gradient function, it will look something like this. You can see that they have very similar shapes but are slightly off, right? But there's actually one value of a which, when we draw the function and its gradient function, is going to be exactly the same. And that value is going to be a is equal to 2.71828 and so on and so on and so on. It's an irrational number. Like pi, it's a very important number, but it's an irrational number. So we gave this a very special name, e. So y is e to the x is essentially y is 2.71, that number, to the power of x. This is a very important number because it's the value at which the exponential is equal to its derivative. So let's say if I were to differentiate y as e to the x, then if I differentiate that, dy by dx, that would also be equal to e to the x. Say we have y is equal to e to the kx, where k is also a number. Then if I was to differentiate that, dy by dx, I'll get k e to the kx. An example would be e to the 5x. If in this case k is 5, right? So if I was to differentiate that, that would be 5e to the 5x, like so. Differentiating e values is very, very important because we need to sometimes apply this in models, which we'll look at in the next video. Anyway, so let's try some of these examples. So let's say we have y is equal to e to the 3x plus 2e to the x. Let's just differentiate them individually. So e to the 3x will give me 3e to the 3x plus the derivative of 2e to the x will just be 2e to the x, like so. Another one is f of x is e to the x brackets e to the x plus 1. First things first, we multiply out the brackets, right? So we'll get f of x as e to the 2x plus e to the x. Now we differentiated f prime of x is 2e to the 2x plus e to the x. So differentiating e values is not too difficult. Just make sure you understand how to do it, but it's very, very important. As I said, it might come up later on in modeling. The e value can also be found from a calculator. So you guys hopefully have this Casio calculator. If you look at the calculator, if you press shift and then you see this ln button here, right? Just above it is a small e. So let's press shift and the ln button, and then the e function should pop up on your calculator. So if you plug in e to the 1, then you should get the value that I mentioned earlier, that 2.71, that irrational number from earlier. So that's how you bring up the e function from a calculator. Okay, importantly now, we also need to be able to sketch this y is e to the x graph. Remember, this is still an exponential graph, right? So it's still going to be the same shape as what we've learned in the previous video, crossing at y is 1 and having a horizontal asymptote at y is 0. But we also need to be able to sketch functions which have been transformed. So for example, y is 4 minus e to the x. This is just us having to practice what we've learned when we learned transformations in the previous videos, right? So if we say f of x is e to the x, y is 4 minus e to the x, I can say is y is 4 minus f of x. That means that it's been transformed with minus and plus 4. So minus f of x, remember, that means it's been reflected in the x-axis. So I'm going to reflect it. And then plus 4 means the whole graph has been translated up by 4. So now the asymptote, which was originally at y is 0, is going to be at y is 4. It crossed at 1. It was reflected in the x-axis. So now it crosses at minus 1 and moves up by 4. So now it's going to cross at 3. So it's exactly the same thing as we've done in the previous chapter, right? It's just now dealing with this specific graph. Let's try another one. So let's say we have y is equal to 6 plus 10e to the half x. Let's write that in terms of f of x. So that's going to be 6 plus 10 f of half x. So first things first, dealing with f of half x, the half x inside means that the x values in themselves are going to be stretched by 2. The 10 means the y values are going to be stretched by 10, so it's now going to cross at 0, 10. And the plus 6 means the whole graph is now going to be translated up by 6. So it's going to cross the y-axis at 16. The asymptote is also going to move up, so it's going to be at y 6. It's going to look something like this. Let's try one more. So let's have y is equal to 100e to the x plus 10. So let's write that in terms of f of x. So that's going to be 100 f of minus x plus 10. First things first, f of minus x, that means it's going to be translated in the y-axis, right? So we flip it, times 100. That means the y value is going to be multiplied by 100. So now it's going to cross at 100 rather than 1. And plus 10 means, once again, translated up by 10. So now it's going to cross at 110. the y asymptote is going to be at y is 10. So these transformations we've learned before, so it should be very familiar. It's just dealing or using them with this particular graph. So go ahead and try and answer the questions that I've listed out later, because this drawing graphs is very, very important for modeling in the next video.